Welcome to the course Excelling with Mathematical Modeling. So far we have been discussing the models which are continuous. So today we switch to discrete models. Now what are discrete models? So in continuous type modeling, which we often implement, we use differential equations. Sometimes it is not the best approach. You will face many situations where you are describing the state of a process for all real time values, and you will find that the process is too long if you use the continuous model, or the process is too much calculative if you use the continuous model. So, in such cases we avoid the continuous one and switch to discrete models. So, sometimes when due to the complexity of the model we avoid the continuous one. Obviously, it depends from model to model, and then we use this discrete time mathematical model. Let us start with an example which will clear it. Say suppose you consider bouncing of a ball. So, if I take the situation that it starts from some initial height, the first bounce, the second bounce, and so on. So, this is the height and this is the time. Say this is T1, this is T2, this is T3, and so on. We know that the differential equation which will satisfy this motion is given by d2s dt square is equal to minus g, and if we integrate it we will get st equal to minus half gt square plus v0 t plus some s0 in the interval t0 less or equal to t less or equal to t1, means in this particular interval, and your height are these. Now, given this v0 and s0, that is the initial velocity and the initial height, we will be able to calculate the time t1. Let us consider the second bounce. You have the same equation st equal to minus half gt square, but now you have a different constant or different initial values. Now it is v1 and s1, which depends on v0 and s0, and also we have assumed that this is frictionless, no air resistance. But we assume one thing, that the ball loses 1/4 of its energy after the first bounce. So, this means if in the second bounce it will loses a 1/4 of the energy that is left, and the process continues. So, in each of the step you have to calculate this V1 and S1, which depends on V0 and S0, and also on this particular property. So, in general if we write, this equation will be treated like this: minus half gt square plus some Vnt plus some Sn. This was in the interval T2, this is in the interval. So, at Tm is the nth time the ball hits the ground. So, if you see that you have a substantial calculations of Vi's and Si's to get the height that the ball reaches after each bounce. So, this is a continuous time model. Now, let us see what happens if we switch to our discrete model. The same situation, only this case we consider the discrete process. So, we concentrate on the sequence of heights, that is this height and this height and so on. So, the ball loses 1/4 of its energy, there is no air resistance. So, the ball must retain 3/4 of its energy from one maximum height to the next maximum height. And from physics, this will mean that with this energy, it must rise back to the maximum height. And what is going to be that height after the first bounce? It is S1, which is 3/4 of S0. This is after the first bounce. After the second bounce, it is S2, which is 3/4 of S1, and so on. So, Sn plus 1 is going to be 3/4 of Sn, where n starts from 0, 1, 2 and so on, and S0 is your initial height. So, you can see that if we process the same thing in a discrete way, then your calculation is much simpler and you can get the answer in the very simple way and very easy to understand. Whereas, in this continuous process, it becomes a bit cumbersome and is a long calculation. So, that is why sometimes it is preferable that you use the discrete way of modeling or discrete process than the continuous one. Now, what are the tools you will be using while modeling this discrete process? So, in the continuous one, you know, we use differential equation. In discrete case, we will be using difference equation. Now, you may not be familiar with difference equation. So, let us go through it. So, this difference equation, it is sometimes referred to as the recurrence relation. So, it is an equation which involves the difference, and one can define a difference equation as a sequence of numbers that are generated recursively using a rule to the previous number in the sequence. Now, let us see what it means. We take an example. For example, you consider this sequence of numbers, say 0, 1, 3, 6, 10, 15, 21. These are known as sequence of triangular numbers, and they are obtained from the difference equation Tn plus 1 equal to Tn plus n plus 1 with T0 equal to 0. So, this is a recurrence relation or a difference equation which generates a sequence of numbers known as the triangular numbers. So, if I substitute n equal to 0, I will get T1 equal to T0 plus 1, T0 is 0 and the answer is 1, which matches with this. You put n equal to 1, you get T2, it is T1, 1 plus 1. So, T1 is 1, this is 2, answer is 3, matches with this, and so on. Similarly, you may have heard the famous Fibonacci sequence. So, here the recurrence relation is Fn equal to Fn minus 1 plus Fn minus 2 with the initial value F0 equal to 0, F1 equal to 1. and the sequence is 0, 1, 1, 2, 3, 5, 8, 13, 21 and so on. So, as usual, if you want to generate the Fibonacci sequence, you have to use this recurrence relation or this difference equation, and here two initial values. So, I will start with n equal to 2, and if you put the value here, it is f2 equal to f1 plus f0. f1 is 1, f0 is 0, and the answer is 1, which matches with this because these two values are already given. I put n equal to 3, I get f3, which is f2 plus f1. f2 is 1, f1 is 1, and the answer is 2, which matches with this. And you can generate the rest of the sequence. So, let us now take a few difference equation and see how we can find their solution. But before that, how a difference equation is formulated. So, suppose you have a relation like this, where your C is an arbitrary constant. It is exactly like differential equation. Suppose you have dy dx equal to, you have y equal to C times x, and if I ask you, you find the differential equation. So, what you will do? You will eliminate this arbitrary constant C and find a relation between x, y and dy dx. It is exactly the same way we do, but here we will not differentiate. What we will do is we take one increment n u n plus 1, and this will be C times n plus 1 plus 5. So, now you eliminate C for equation 1 and equation 2. So, you calculate C and substitute it here. So, that will give you u n plus 1, C will be u n minus 5 divided by n into n plus 1 plus 5. You simplify this a little. So, it is u n into n plus u n minus 5n minus 5 plus 5n divided by n. This and this cancels, and you get n u n plus 1 equal to n plus 1 into u n minus 5. So, this is a difference equation. We now take another example. You have u n is equal to a 2 to the power n plus b minus 3 2 to the power n. We have to obtain the difference equation by eliminating the arbitrary constants a and b. So, what you do is you first write what is u n plus 1, which is a 2 to the power n plus 1 plus b minus 3 to the power n plus 1. And since we have two arbitrary constants, you have to again write u n plus 2 equal to a 2 to the power n plus 2 plus b minus 3 to the power n plus 2. So, what you will do here is, if I name this as 1, this as 2 and this as 3. So, I will eliminate and find out the values of a and b from 2 and 3 and substitute it in 1. So, 2 and 3 can be rewritten as. So, I write u n plus 1 equal to 2a 2 to the power n. So, what I did is I write 2 to the power n plus 1 as 2 to the power n into 2. So, that is why this 2 has come, and here again minus 3 to the power n into minus 3. So, minus 3b minus 3 to the power n. Similarly, the third equation can be written as u n plus 2. This is equal to 2 square. So, 4a 2 to the power n and minus 3 square, which is 9, plus 9b minus 3 to the power n. Now, we are solve these two equations for a and b. So, you multiply this equation by 2 and this equation by 1. And you get 2un plus 1 equal to 4a 2 to the power n minus 6b minus 3 to the power n. And this is un plus 2 equal to 4a 2 to the power n plus 9b minus 3 to the power n. Subtract it. This is 2un plus 1 minus 2 minus un plus 2 equal to, this cancels, and this is minus 15b minus 3 to the power n. So, this implies that b is equal to un plus 2 minus 2un plus 1 divided by 15 minus 3 to the power n. So, this is the value of b. Now, you can substitute the value of b here and calculate the value of a, and if you do that, you will get, so I write equation, this equation. So, I write un plus 1, that is equal to 2a 2 to the power n minus 3b minus 3 to the power n. So, this b into minus 3 to the power n, I can get it from here, and that is 2a 2 to the power n minus 3 times, this is un plus 2 minus 2 un plus 1 divided by 15. So, this and this 5. So, this will give 2a 2 to the power n is equal to un plus 1 plus un plus 2 minus 2 un plus 1 divided by 5. So, 5 un plus 1 plus un plus 2 minus 2 un plus 1 divided by 5. So, I get 3 times un plus 1 plus un plus 2 divided by 10 to the power n, and that value is e. So, now I have to substitute this value of a and this value of b in equation 1 to get the required difference equation. And if I do that, I will get un is equal to, so a into 2 to the power n. So, that will give me 3 un plus 1 plus un plus 2 divided by 10. So, I just multiply this here, and plus b minus 3 to the power n, that will give me un plus 2 minus 2 un plus 1 divided by 15. So, if I simplify them, I will get this as 30. So, I get 30 un, which is equal to 9 un plus 1 plus 3 un plus 2 plus 2 un plus 2 minus 4 un plus 1, and this is equal to 5 un plus 1 plus 5 un plus 2. So, if you cancel 5 and simplifying, you will get un plus 2 plus un plus 1 minus 6 un equal to 0, and this is the required difference equation after eliminating the arbitrary constants a and b. Now, this difference equation can be linear or it can be non-linear. So, an example, xn plus 1 equal to 2 times xn minus 7, and a non-linear one, xn plus 1, I just make it a non-linear term minus 7. So, this is a linear equation, this is a non-linear equation, and the non-linearity is here. Again, if I write xn plus 1 equal to alpha n times some xn plus beta n. If alpha n is equal to alpha and beta n is equal to beta, where both of them are constants, then we say that this difference equation is autonomous. However, if they are dependent on n, then it is called non-autonomous. So, an autonomous equation is xn plus 1 equal to 2xn plus 7, and if I want the non-autonomous one, I will make this as say 2 by n xn plus 7 by n plus 1. So, this is an autonomous one, this is a non-autonomous one where the constants are dependent on n. Next, we solve two special difference equation which we will be requiring in our modeling of discrete cases. So, say it is C0 un plus C1 un minus 1 plus C2 un minus 2 equal to some Fn. So, this is called a linear difference equation with constant coefficients. If Fn equal to 0, we say that the equation is homogeneous, otherwise non-homogeneous. And the order of this difference equation is the largest argument minus the smallest argument. Now, what is the largest argument? That is this n. What is the smallest argument? That is n minus 2. So, it is n minus 2, which is 2. So, order of this difference equation is 2. Now, let us find the solution of homogeneous equation. So, the equation is of the form un equal to some k times un minus 1. So, as you can see, there is no function of n and hence it is a homogeneous equation. You can put this in this form also. So, there is no Fn here and that value of Fn is 0. So, this is a homogeneous equation. So, if I put n equal to 1, then I get u1 equal to k times u0. I put n equal to 2, I get u2 equal to k times u1, and u1 I know it is k times u0. So, k times u0, so it is k square u0. N equal to 3, I get u3, it is k times u2, and u2 we have already proved that it is u square u0. So, I just write k square u0, which is k cube u0. And we can continue like this, and you will get un is equal to k times un minus 1, which is k to the power n into u0. So, the general solution of the difference equation, you can name it, or you can just write un equal to k times un minus 1 is un equal to some c times k to the power n. So, you replace this by arbitrary constant, where c is the arbitrary constant. So, basically what you need to remember is that if your difference equation is of the form un equal to k un minus 1, then the solution is un equal to c into k to the power n, where c is an arbitrary constant. So, with this we stop today for the first part of this difference equation. In the second part, we will be taking more examples and more different kind of difference equation. Till then, bye bye.